my series where I'm developing a web server from scratch in C++. Actually, might be deviating away from C++ tonight if I get pretty far, because I'm soon going to need to dive into the wild world of web app development, which I'm planning to use React in order to implement. React being a JavaScript framework from Facebook. So, if you haven't seen the stream before, there's a link below to the OneNote notebook. I just realized if you're watching this later, you might be watching it through YouTube, so there is no link. But on my Twitch channel, there's a link. And in my notebook, you'll see a log for every single stream. We're on stream 32 now. You can see kind of how we progressed. Can I drag that more? I can't make that any bigger? Oh well. So yeah, we started off back at the end of June building up some utility classes to handle URI, message headers, UTF-8, abstractions for the operating system, and then around mid to late July, we started work on an actual web server and a host for the web server, and a reader and writer for JSON, which we use for two different things, our configuration file, and also for the content of WebSocket messages. Then at the end of July, we added WebSockets, which we're now building up an example Chatroom using those WebSockets. So, tonight what I'm hoping to do, since we just got the chat room off the ground, but it doesn't really do much, we're going to add to it some basic functionality. And I thought of three things we can add. First is lurking, where you can basically stay connected to the chat room and not have your presence known, but you'll be able to receive messages but not send any. Then there's nickname assignment and reservation. And I'm putting this in because I'm planning to, pretty soon hopefully, make it available for the whole world while I'm streaming. And maybe even after I'm done streaming, like in the background, which I'm kind of terrified of doing, because if I leave some bugs in there, people can exploit it and like drive up my web hosting costs. But for now, we'll start with just a closely supervised opening up to the world. But this nickname assignment reservation will allow people, while watching my stream, to kind of connect into the chat room and get assigned nicknames, like pick a nickname. And in order so that people don't steal each other's nicknames, we'll have some kind of simple challenge answer, probably automated into the web app, where you have to, your web app has to kind of know a secret key. And we won't use like cryptographically strong stuff, just like a word that's hashed. And the server will give a challenge that you have to append your secret word to, and then respond with the hash of that, and then that'll make sure that your connection is allowed to use the nickname. Oh, hey there, Ubi. And the fun part will be message publication and distribution. So what we'll want to do is any client that posts a message, we want to kind of send a message back to any other connection to the same server, so that other people can see messages you post, right? That's the whole point of a chat room. To make this actually work with my real web server, one thing that's kind of missing now is this concept of connection upgrading in the server. The server's got to kind of pass off the baton of the connection to the web server. Web server knows how to do that, but right now our HTTP server doesn't know. So once that's working, the fun stuff begins. I'm going to dive into React to try to make a web app that you all can hopefully get to from my public website and play around in my chat room. Okay, Ubi, you opened the implementation of URI and Elixir. Does it look similar at all to what I have? You just have to remember, mine's all written from scratch, so it's going to be pretty gory. But something that's not written from scratch, that's relying on other things, is probably a lot easier to use, right? Let's take a look. Why did that open off screen? Here we go, bringing it on screen. Yeah, look, it's all the things that we are familiar with: scheme, path, query, fragment, authority. Right. Yep. Yep. That's what I'd expect. Do they reference the RFC here? They do. Look at that. That's awesome. Everyone should do that. Yep. Yep. Yeah. See, I was indoctrinated into the Society of Elixir and Erlang earlier today by Ubi. And anyone who's watching this should go follow Ubi, by the way. Looks very cool. I always like to look at new stuff. I get the sense of how it works, and this actually helps because I know URIs. I can kind of see how this works. That's interesting. They're handling Unicode, hopefully correctly there. Cool, awesomeness. So there you go. There's a no, I keep saying Erlang, but it's really Elixir, right? There's an Elixir implementation of a library that we implemented in this stream in C++. Cool. Oh, Ubi, by the way, I was watching a stream earlier. I kept thinking, man, I wish I could give him my spare monitor because I don't know about you, but for me, it really helps to have two monitors because I can put my Twitch dashboard off to the side and not broadcast it to everyone. And also, I have a breakout chat of Twitch. I pick Chatty, which makes a little ding sound for me, so I know when people are posting the chat. So I just turn my head and I can see the chat. Really, I found that really useful. Yeah, I'm sorry to hear that, but yeah, I'm like, man, I wish I could. I have this extra monitor here. I wish I could like give it to him, but he's way over on the other side of the country. Anyway, yeah, I think it definitely, at least for me, it really helps to have like the information I want to have on stream, and then my off stream stuff kind of makes me feel a bit more relaxed about you know, don't want to show people everything, right? Like my email, all that stuff. Don't want to accidentally show that stuff. Anyway, let's work on this chat room, shall we? So, I think we already have this concept of lurking because I made it so that you have to actually send a message that says set nickname in order for your nickname to get added to the room. We don't have this assignment registration. We don't have the challenge part right now. Right now, if you can set your nickname, you could set your nickname to some nickname that's already being used, and it'll allow it. Oh yeah, that's the other thing, Ubi. I was looking at that FHIR. I'm guessing you're implementing a site to deal with healthcare, but I missed the beginning in your previous stream, so I'm kind of got lost a little bit. One thing that might help maybe is if you put in a little intro panel under your, where you have your panels. So, and I've been watching other streamers, and I like it when they have like a little, I don't know, not a frequently asked questions, but maybe like a what is this about, and then like a little bit of text below that in the panel that kind of gives an intro. I think that helps people who might jump in and be a little lost at first. Cool, yeah. Maybe make a business out of that, yeah. So I'm still a newbie, so don't take my word for it. But I've been watching some more popular streamers and kind of trying to copy some of the things they do that seem to work out pretty well. Cool. All right, this simple challenge answer. The idea I have is that when you first set a nickname, what I kind of want to do is this. In addition to your nickname, we'll have, I don't know what we want to call it, hashed. How about we call it public key? Because it's going to be the same kind of concept. We'll have let me think about this. We'll just make it a simple password that's generated random in the web app side. and it'll hash it, and then hash will be the public key. So in this case, it's, I don't know. Let's just do something simple. Let's just use the SHA-1 library that we have, right? SHA-1. Oh, cool. Going to Cali for an interview. Awesome. Yeah. Good luck to you, man. Oh, really bad for you because of code change. You knew what to do, but you got nervous about it. That's normal. Everyone gets nervous about it. I used to interview lots of people because I was on the other side of the table, so to speak. I was the interviewing manager. I always felt really kind of bad for the people that would come in and be nervous. I'd always try to break the ice with them and say, hey, before we start the interview, you want something to drink? Or you want to just chit-chat about non-interview stuff first? And I always hope that helped. But yeah, I totally understand. I feel for you. My take on it is if they're cool with it and like they try to break the ice and make it so you're not so nervous, that's the company you want to work for. If they don't give a crap, then that might be a warning sign that they don't care about you when you're interviewing with them. Do you really want to work with them later? Anyway, that's just my random thought about that. They did what? Were they cool or not cool? Hopefully they did care. Cool. All right. Yes, I want to use SHA-1 here. All right, cool. Yeah, that's always nice. Even if you like don't get a job, like it's nice to like meet people in the industry and maybe they pass on a positive word or they know someone else who's hiring and they can let you know. Can't hurt. Can't hurt to be nice, right? Okay, I'm gonna use SHA-1 to hash something. Let's make a secret. The secret will be PogChamp, because this is a Twitch stream, right? Const auto public. We can't use public because it's a keyword, right? We'll make it public key, secret key. And what I want to put in here is this key. So I'm going to turn this into a constructed string. Whoa. String extensions. I'm trying to be conscious about when I say and minimize that, but it's really difficult to have it to break. Public key.c string, right? Okay, so my idea is that if you set a nickname that's not registered yet, you get it registered with your public key. But if it's already registered, you'll get a challenge. Basically says, okay, that nickname exists. Here's your challenge. Hash this thing with your secret again. Yeah, maybe I'm not thinking about this right, but it's a typical challenge answer where the server sends a challenge that only someone with the secret key will be able to solve. Actually, I think the way we're going to do this is we're going to turn it around. All right, maybe I just need something that's reversible. Or maybe we just presume that these messages are secure anyway. I'm thinking. I guess we do need something that's reversible, right? So let's just keep it simple. We'll call it the key. And we won't bother about hashing it or anything. We'll just presume that this is all over something that's already secure. We'll just call it key. So basically, the requirement will be you have to register with the same key. If you register with the wrong key, you get it denied. So let's test that. We will assert at this point that we get back an OK of some kind. Something like nickname set result. And result will be, we'll say success, and we'll make it a true. And then clear the messages. And then the get nicknames will return that. So let's make another test now. Here it will be set nickname twice. So we'll set it. It'll say it's succeeded. Then we'll clear, and then we'll try to set it again from another connection. So that means I need another connection. How hard would it be to add a second connection to our test? I guess we would need 2 WebSockets, 2 client connections, and 2 server connections. And 2 messages received. Could you add triple double quote for adding strings that do not require escaping the character? Not in C++. Triggers me to escape the characters all the time on double quote. Yeah, this having to escape everything, that's because we're double encoding it, right? It might be easier to read if I did something like this. JSON message. Of course, I have to say that it's of type object, and then I can just fill them in one at a time, right? Set type to set nickname. Nickname is Bob. Key is key. And then I can just say send text message. Is that better? I guess so. I kind of just, one thing I don't like about it is I have to set it up in 4 different statements like that. What would I do this also when I'm, okay. We'll do it for all these. So I just have to say expected, what are we calling it? Response 1. Set type this guy. Success, true. And then this. Is there any way to convert a struct into the JSON? I tried to do that back when I was working on this JSON class, but the problem I ran into, which is probably just my ineptitude in overloading class methods. Let me show you. I wanted to do that with an initializer list, where the initializer list was consisted of pairs, like key value pairs, but it was coming up as being, what's the word? Ambiguous. It didn't know if I was constructing a JSON array or a JSON object. So I did have an idea about how to fix that, which would be to have an explicit method called make JSON object or create JSON object, and then it would take an initializer list again. But I haven't worked on that yet. I mean, I know there are JSON libraries out there that do that. There's one I'm thinking of that uses a lot of templates to do it. Yeah, I'll get to that. Just need to think about it a little bit more. Okay, so let's make another one of these. type nicknames. Nicknames. Here's where I can, oops, I can do a little bit of that. I can, if we know it's an array, we can use the initializer list syntax. Let's just say Bob. Why do I have that in there? Oh, that's just in the wrong place. This is 2. And that goes there. Oh, this, hold on. Let me finish this first. So, this was like message 1, right? And then we'll have message 2. Send text message 2. Actually, I have to be careful here. I have to say 2 encoding. Otherwise, it's going to try to interpret it as a string value and not the encoding of an object. 2 encoding. All right. Okay, this is sort of a rewritten version of the test I copied. Okay, this one we're going to set it twice. So message 2 is again, oh, hold on. I really need a second connection for this. I guess I can just bite the bullet and have a copy of these. Or hold on, why don't I just make these arrays? Why not? 2 of them. Oh, because this I can't do. We'll move it. Move it to our setup here. So for const, well, yeah, for const, say, no, not const, 0 to, I want a constant though, num mock clients. 2 of them there, 2 of them there, and 2 of them here. Let's move that as well. Oh, I lost the other code. Oh well, I know it's something like that. Yeah, of course I haven't declared it yet. And let's declare it up here. This is the number of mock clients to connect to this, to the chat room. Okay. And that needs a semicolon. And this is this. And there's both a client and a server, and that's client. Actually here, I suppose we can be a little bit smart and do system abstraction sprint f. This is going to get a little bit long, so let me break it up. Mock client, and we'll just print the number. Come on, mouse. Fighting me. Don't fight. Okay. WebSocket client server and messages received. Right, so I suppose we can set this up the same place we set up the other thing. Am I going too fast? We had one connection, now we're making n connections. How do I pronounce the nickname? You told me. I just say moo, like a cow saying moo. And that's just something someone started calling me in game. I play World of Warcraft, and people kept getting tired of saying Raimu because it's two syllables. So our guild leaders started saying moo. I'm like, okay, that's better. Easier to say one syllable than two. Okay, we're gonna make client and server and then connect them here. You just need to put these eyes in front of everything. Oop, put them in the wrong place. They go to the left of the arrow. And that goes there, and that goes there. Okay, here's a case where we need to capture eye. Oh, I need to capture eye in all three places. Oh, well, sleep well, Ubi. Thanks for stopping by. Yeah, I'll tune in if I'm online then. UI stuff, cool. Love to see that. Take care. Content for YouTube. Yeah, you know what you can do is like you're locally recording yourself streaming. Just after you're done, you can edit it, right? And your YouTube content could just be edited content from your stream. Just an idea, but yeah, good night. Okay, server. What is it not like server? Probably because it needs a specific connection here. That's what it is. And this needs a specific client connection, as well as a WebSocket. There we go. So this first test will exclusively use one client, and then this one will use one client here. But here, the idea here is we're going to make the second client try to grab the same nickname with a different key. Let's call this key 1. So we'll basically copy this. And here the test is getting long, so I'm going to put it into sections. Set nickname for first client. Set nickname for second client, trying to grab the same nickname as the first client. This is what we want to avoid. We don't want the second client to get the same nickname. So it'll try to get Bob, but with a different key. Have like poggers, for example. Key 2. And this is message 2. Actually, you know what? We can just reuse message. Then I don't have to have these silly little numbers, right? Same thing here. What I can do is I can just say message equals this type. Like that. Because we support the move assignment operator, right? So here we'll send it from the other WebSocket. And we'll expect false coming back. And here we're going to reuse the same instance, just assign a new one. So that's what we want. That's what we want to see. Client chat. Oh, am I in the right directory? Okay, it's web server chat room plugin test debug chat room plugin tests. All right. Whenever you see an error and when you double click it, it goes to a library like the standard library or Google test. It's usually because it's a template and you're using the template in your code. So you usually have to scroll down until you see the first reference to your code, which is right here, to see what template you're using. In this case, we're using assert equals invokes a template, so. And the error message is we can't, okay, it doesn't know how to compare these two. Oh, because messages received is now an array. That's why. Right. Okay, let's run our test. So we failed, of course, because we don't get a success nickname set result back from the chat room because it's not programmed to do that yet. So let's program it to do that. So in this receive message in the chat room plugin, this is where messages come in from the WebSockets. We get session ID, which is unique. It's incremented every time a new WebSocket connection is made. So we use it to associate the message to which client or which WebSocket connected in. See here, we can start with saying that we're always going to send back the response. Like this. Like we did for get nicknames. We'll have the type be set nickname result, right? Nickname set result. Maybe I should make it consistent with the command and call it set nickname result. That makes more sense to me. And we'll just always say that success is true. Though that should make, oh, hold on, I didn't send it. I have to send the message, right? This should allow one of our tests to pass. I didn't. Oh, that's right. Again, I keep running into this. The way I have my build system set up, if we change the plugin, but we don't rebuild the test, the test isn't getting the latest plugin because it's the test post-build step that makes a copy of the Chatroom plugin for the test to run. I'm actually thinking I should change that build system thing, but for now, let me just do. This is my workaround right now. I just say rebuild only the test. Okay, so it got further. $3.16 this time in our test. Oh, I see what happened. Yeah, let me fix this. See, I got myself into trouble by putting little instance numbers and having different instances. I really should just reuse the instance. So, like this, message equals a new one, set it up. And then again, the response is a new one, like that. That was our test we built, right? Okay, so set nickname works. Set nickname twice doesn't work. And it's illustrating the problem that the second client is able to get the same nickname as the first client. So here's where we have to be a little bit clever, right? What we'll do is we'll have a registration. Right now it'll all be in memory, but eventually we'll want to put it in a database. So it's going to be information that persists about a user even if they're not connected. What do we call that? That one is the user. What is this? User information? Or user registration? This represents the registration of one. How about, actually, it's not just a user, it's a, we'll call a user someone that's connected with the WebSocket. We'll call this account. This represents a registered user of the chat room. So the account will have the nickname. User's nickname. It won't have a WebSocket and it won't have an open. But now the user can have an account. This is the really it's going to be what? Pointer to an account. This hold on. I've got to be careful about this. What I want is I want the chat room to have a collection of accounts. Let's just put this back to nickname because then we'll have that be the common key. So the room has users and it'll also have accounts. These are the registered users in the chat room, keyed by nickname. This will be the users currently in the chat room, of the chat room. A string, and this is account, and this is accounts. Okay. So okay, so what we can do is we can see if there's an account present yet. Oh, and I forgot. We wanted the key to be in here, right? This is the... Should just cut to the... not cut to the chase, what am I thinking? This is really just a password, isn't it? Why do I have key? Oh, because they're different. Well, we'll call it a key, because it's not really a password. This is all sort of just to demonstrate anyway. This is the this is the string that the user needs to present as for the value of key when setting their nickname in order to link the user to the account. Okay. So we will here say a auto account entry is accounts find. Oh, we have to do this first. Find the nickname, which I guess we can cache. Now, we find the nickname. If it's not present, so if account entry equals accounts.end, or well, let's make it minimally work. I was gonna say or it exists and the key matches, but what we'll do. No, hold on. We need this. We need this. It exists or it's matching. Because what we can do is we can have another test where we just open two WebSockets with the same key, which you can do. Like in Twitch, you can have two different web browsers or two different chat clients in the same room, right? And they're both you. You're just seeing it in two places. Account entry arrow second dot key equals, I guess we need to get a key, right? Const auto key equals message key. Okay, this should be string. This should be string also, actually. Then we'll let them use that nickname. And we'll say account. And here's where the account gets added if it wasn't there before. That should be there, right? And then account dot key equals key. Account. Hold on, why do I have nickname there? Oh. Yeah, account. The nickname is the key of the account anyway. I shouldn't use the word key, should I? Maybe I should just fix this. This is really the password when it comes down to it. Yeah, I don't know why I was thinking I should call it key. It's really password. It's like, why try to call it something when it's not? I don't know why I was resisting calling it password to begin with. My reasoning is that it's safe to put it in the clear because this whole WebSocket should be encrypted anyway. It probably makes sense that when we eventually store this in a database or something, we wouldn't really store the password. We would hash it or securely hash it. But we're going to start simple. All right, so this needs a password here. Password. Password there and password there. Password here and here. And here. Okay, and then we have to handle the else, right? Else. Let's set up the response here. So we're always going to respond. But we'll respond success here and fail there. All right. And there we go. So there, the second user got denied. Let's enhance this test to have a third client which uses the correct password. But with the wrong password. Set nickname for third client, trying to grab the same nickname as the first client with the correct password. This is allowed, and a real world use case might be the same user joining the chat room from two separate browser windows. So here we'll use number 2, which means I have to go and change this to 3, which is no big deal. Reuse that guy. And reuse that guy. Cool, so there we go. It's probably a good sanity check would be to list the chat room, to list the nicknames, right? And just for a little twist, what we'll do is we'll have the second client Have this second client get the nickname list. Wait a minute. I don't need to clear it there. So it'll be through 1. We should just see Bob, and we should only see Bob once. I think this is actually going to fail. Let me see. Yeah, we see Bob 3 times. That's not good. I was actually expecting to see it twice, not 3 times. So probably the second one, it got set even though it shouldn't have. Hold on. It shouldn't show up 3 times. I'm curious to see why. So what if we put the breakpoint in there and start the debugger? And then we take a look at the chat room. Why am I calling it oh, I know why I'm calling it server. It is a server, isn't it? Oh, what's the name of the chat room? Oh, it's not accessible. Does it show up as a global? What would it be? It's called room, but it's inside this anonymous namespace. Can I look at it here? Maybe not. No. I guess what we'll do is we'll set a breakpoint in this receive message. And now it's just this. 9 users? Whoa. Why are we getting 9 users? I don't understand that at all. Huh. How come we're getting 9 users? That's really weird. Okay, so let me stop that. And let's see what we have at the very beginning. Weird. Okay, try again. All the way over again. We have 6 users somehow. So where do we actually set the users? I think I have a bug. Let's set a breakpoint there. Retry. My dog gets a little enthusiastic at bedtime for the kids. Okay, that's the first time. And here's the second one is here, where I is 1. And then again, when I is 2. And then again, when I is 0 again. Oh, I know what's going on. Yeah, we didn't clear this global. Okay. This unload delegate is not clearing the room out like it should. Which is okay, that's a good catch. So let's write a test specifically for that. Actually, it's kind of hard to do that because I have to repeat all this setup. after calling the unload delegate. Okay, it's not too bad. We just repeat a little of this part. So the idea is we would set the nickname and then unload the plugin and load it again, and we assume that there's no one in the room, right? So room cleared after unload. So here we set up Bob to be in the room. Have Bob join the chat room. Next, unload the chat room, and then load the chat room again. And then verify nobody. Verify the nickname list is empty. Okay, so unload the chat room is easy. We just call unload delegate. Load the chat room again. We're going to repeat a little bit of the setup. Actually, what I think I'll do is I'll put this into another method. Or do we just call setup again? Yeah, why not? We'll just call setup again. Which means I should probably just call tear down. Well, we could just combine these then. Reload the chat room. Okay, verify that it's empty. So that's as simple as copying the part. Where is it? In this expected. No. Did I lose something? Where do we actually get nicknames? I think I did lose that. Okay, let's look at Git. CD web server Git GUI. Okay, I should have checked this in earlier. I already lost it, so I will have to copy this again. No biggie. This got blown away from here by accident, I think. So yeah, set nickname. We should set it, and when we get our list, we should get it back. So we're going to copy this and reuse this in our new test down here. We should have an empty list. This we shot it clear. We should do this actually as a rule every time after we assert. Just in case I copy this around, right? Alright. Right, so the room is not cleared. Where's that test here? Yeah, we see Bob shows up 4 times. So let's fix the problem. The problem is in this unload. It's only unregistering, but it really needs to clear the room as well. So let's say room equals room. And does that mean we have to... Okay, that would have been the cool thing to do, but since we can't, what should we do? We really should clear all of this. Hmm. I'm thinking in normal use we don't need to do this because after the plugin is unloaded, it's unlinked and then all memory is destroyed. So we really only need to do this because the test framework is reusing the global state of the chat room. Oh, and you know what? We're also forgetting to call start and stop. That should call impulse stop. No. Oh, this. Impl? Hold on. No, it's... Oh, actually I don't need to capture, do I? It's just room.stop. And before we register, we'll do room.start. Okay, so we stop the room. Users clear, accounts clear. Anything else? Don't need breakpoints anymore. So clear those breakpoints. Next session ID, I guess we should it doesn't really matter. I'm just going to leave it the way it is. Users have closed. That we want to set that to false. We cleared the users. That's handled by the stop. Okay, that should clear things up a little bit. And I need to rebuild only our tests after we change the chat room. We got invalid JSON. Okay, I didn't construct it right. Really? Let me see what that does. That should have made an empty array, JSON array. It didn't. How come it got a type invalid? Was it because an empty initializer list just calls the default constructor? Okay, so that's actually a problem. Let me make a note of that. I need to maybe not use the initializer list syntax for JSON. So note, JSON standard initializer list. What's the syntax of that? Standard initializer list. I'll just copy this. Whoa. Right, that isn't called for. Can we fix this, or do we need to make separate factory methods? Keeping in mind we also want a convenient way to quickly make a JSON object as well as an array. Isn't call for, yeah. I'll remember what that is. So yeah, for now, we have to do like this, only we have to say array, which is kind of dumb. Okay, so we passed the room cleared after unload. So let's go to the first failure here. I thought that would pass all our tests, but I guess not. Interesting. So the nickname came back. Oh, okay. I see what happened. We didn't clear the message received after the first one. Okay, so that fixed that one. Now for set nickname twice. 392 is where it's failing. So we expect to see just Bob, and what do we see? Bob? Oh, yeah. I remember that. The problem is that Bob is showing up twice because he's coming in from two separate WebSockets. So I think what we want... We don't want Bob to show up twice, even though he's connected twice. And I'm a little lost here. I think what we want to do is in get nicknames. Where is that? We should actually split this up into separate methods. Maybe we should do that now. Because this is set nickname, really, and this is get nicknames. Well, let's fix the bug first, and then we'll refactor. This should only add it to nicknames if it's not already in there. So what is nicknames now? It's a JSON. Let's temporarily form a set called nickname set, and that'll be insert. That'll be standard set of strings. Don't need the return value for insert. So what we can do here is just for const auto nickname in nickname set. I already erased it. So nickname, it was nicknames.add, right? And then nickname. Yeah. Are we including set? No, we're not. Let's do that. That's a polite thing to do. So that'll fix our bug, right? No. Shoot. Oh, because I didn't rebuild the tests. That makes me really want to fix this too. We'll do both things. We'll fix that, and then we'll also refactor our chat room after we check in this code. Yeah, so all of this was add passwords to user accounts. This is all in the chat room plugin. So don't let, well, first, user provides password when setting nickname. Don't allow a password, a nickname to be set if it's already been registered with a different password. And only list nicknames once, even if the same user has multiple connections to the chat room. All right. So let's refactor this first. I want to pull all this out into a method called setNickname. So it needs the message, which is a JSON object. It needs the user entry, which is a really ugly type, but really it's an iterator into this map. So that's a const iterator. User entry. Actually, I think it needs to be not a const iterator because we're setting the nickname. Yeah, there we go. So this method handles the set nickname message from users in the chat room. This is the content of the user message. This is the entry of the user who sent the message. Alright, so we're going to have the same kind of thing for the other method too. That one was get nicknames, right? Get nickname list. That's what it's called, right? Get nicknames. Get nicknames. And that has this body in it. So we can reduce this now to set nickname message user entry. And this one to get nicknames message user entry. Very nice. Okay. Actually, maybe we should move this condition. We should probably move this condition inside the set nickname. Yeah, we'll say message. Well, if it didn't have a nickname, then this will return an empty string. So we'll say if nickname is not empty. Well, we don't even want to search the accounts, actually. Hold on. I guess it doesn't hurt. What I want it to do is go into the else, say false if they try to call set nickname and they don't provide any nickname. We could also replace this with a function to like validate that the nickname is legal. You know, like no bad words or something. Right, so then I can reduce this to just this. And let's run our test to make sure nothing broke. So this is just a refactoring step. Chatroom plugin refactoring. Extract method set nickname. Extract method get nicknames. Sorry about that. Bump microphone. By the way, if you're watching, all this code is on GitHub. There's a link below to the top level repository. And once you clone that, you'll need to get the second level repositories. For example, there's a different one for JSON, different one for SHA-1, different one for HTTP. I use a tool that I wrote called Mugget. So you would do something like Mugget select main to select this main.xml and then Mugget pull. And that'll clone for you all of these sub-repositories. So it's kind of like repo for Google Android. Actually designed it based on how they format their manifest files. So that's if you want to get your own copy of the code to follow along. So sometimes I jump around pretty quick, and so it might be easier if you have your own copy of the code in front of you. That way you can just refer to that and not get so lost when I jump around. Right, so we have lurking pretty much automatically because you're not required to set a nickname. Now we have this, and our simple challenge answer is basically that you have to call set nickname to reserve it. And if you're the first, that's fine, but if you're not the first, you have to have the same password. So let's do message publication distribution next. Make a unit test first. So this is where we actually do some chatting. So let's copy this. test, and we'll change it. Because I want to have 2 users in the room. Set, so really it's Bob joins the room. And then Alice joins the room. And Alice's password will be feels bad man. Keeping it to the Twitch theme. Okay. And I guess for a sanity check, we should have one of them get the list, right? So Bob peeks at the member list at the chat room member list. Get nicknames. We will get Alice and Bob. So far so good. So then we'll have Alice say something. Alice says something. So that would be type post. Well, no, something specific. Post message. Oh, message, I don't like that. Word is overloaded. Chat? No. Oh, how about just tell, right? Because that's like chat room parlance. A tell would be something that you say in a chat room. Message.set tell, we'll say, hey guys. So it's sent from Alice, which is this client, right? Oh, we need to have this come from 1. 1 is Alice, 0 is Bob. Alice says something. So what we'll expect is we'll expect the same message for both Alice and Bob. What we'll expect is a type tell. Tell, hey guys, but now in addition, we'll have sender, Alice. Oh, I forgot to give it a unique name. This is tell. Right, we're reusing message and we're reusing the expected response as well. Okay. So, of course, this isn't going to work. So no one's getting the tell. And we can actually do this, turn this into an expect to verify that neither Alice nor Bob gets the tell. Actually, does it make sense for Alice to get the tell back? I guess so, because when you type in a chat room, you get what you typed spat back out at you as if you were someone else, right? Only it says your name. So we have to implement tell. Let's define the method first. Modeled after this get nicknames. This method handles the tell message from users in the chat room. Excuse me. Sorry, I was just checking my little overlay. Okay, tell. I guess what we should do, hold on. Something like this. We will get the tell from it. If it's empty, we'll just return. And we should actually have a test for that. Alice says something, and then we'll have Bob's says something, but it's empty. Right? Here we do not. So we'll expect true that messages received is empty for both 0 and 1. And we don't have any expected response. Right, so if it's not empty, we'll make a response type tell. Tell is the tell again. And we're going to send it to all users. So it's actually very straightforward. Just do this. And we can save ourselves a little bit of redundancy by only doing the encoding once, response encoding. There we go. It didn't work because I didn't rebuild the plugin. I was actually going to do that and I forgot. Project only rebuild. There we go. Still not working. Oh, because I wrote the function by not calling it. That makes sense. It's if type is tell, then call tell. And yeah, I gotta rebuild the plugin too. I mean the test. That's interesting. So 501. So that's Bob. Bob saw nothing. Alice saw 3 tells. But they didn't have the sender in it. Oh, we forgot to put the sender in there. But why did Alice get it 3 times? Oh, hold on. I think I know why. In tell, where's tell? Look at the wrong file. Okay, in tell. Where are you? User entry is there, and I used user entry here by mistake. So it's user. User.ws, right? Was it user.second.ws? Is it because it's const? Yeah, that's why. We're actually modifying the user's WebSocket by sending text to it. And I keep screwing this up so many times. I'm gonna do the CMake repair next time. Next thing I do. Okay, yeah, we're just not setting the sender. I forgot to do that. Sender is user entry second dot nickname. And again, I gotta project only rebuild the tests because of the post build step. Whoa. Oh, I have mistyped something. Line 517. Yeah, that should be a 1, not a 0. There we go. So let's check that in, and then I'm going to fix the CMake stuff. So add the this is Chatroom plugin. Very important check-in because this is add the ability to talk in the chat room. Very important, right? Okay. So the problem that it's in the CMake that we're gonna fix now. It's actually easier to see in Visual Studio Code. So inside Web Server, there's the Chatroom plugin, and then inside the Chatroom plugin, there's the tests. Right now, the CMake list for the test has this custom command. Whoop, right here to make a copy of the Chatroom plugin, if it's different, to copy it to the output directory of the test. Problem is that this is a post-build command on the test. So if you change the plugin but you don't change the test, the plugin won't get copied to the test output folder. So I think a better way to do this would be just to make sure that the plugin and the plugin's test end up building to the same directory. So I'm going to just do that. So we will not add a post build command. Well, hold on, let's see. I want target file dir of Chatroom plugin to be CMake current binary dir. That's what I really want. Let's see if that actually works. I'm not sure if that's going to work as is. I think we need to do it actually before the add executable and all that. Maybe up here at the top. So if I look now at the web server Chatroom plugin debug, I just see the Chatroom plugin. So what I want to see is when I build this, the test should go there now. It didn't. Okay. Actually, let's tell it to rebuild it actually, just to make sure. Okay, so that didn't work. Let's look it up in the manual, shall we? I have this offline manual collection called Velocity on Windows, and on the Mac there's a version of it called Dash. It's giving me problems lately. It's saying that the CMake is broken, but I can still get to the documentation through the top level main index. I think it's variables and then CMake current binary dir. I thought that was the variable that I needed to set, but maybe I'm wrong. Oh, hold on. No, I'm doing it in the right place. Maybe this doesn't quite work. What if I put it in this thing before it calls add subdirectory? Okay, I don't think that worked because actually I can look at these properties to see the output. You see, it's still going to test debug, so that's not working. Maybe binary dir. No. Time to Google to the rescue, right? Okay, cmake change output directory. Ah. Cmake runtime output directory, library output directory, archive output directory. Do I really have to set all three? Probably don't. Probably just need this, right? And I would rather put that in here if I can. Okay. Okay, good. Cool. Reload the projects. What I want to see is, yeah, okay, that's good. So, yeah. See, now we have the tests in the same directory as the plugin, so as long as we do build, either one gets updated, the test will always be running the right plugins and they'll both be current now. So now I shouldn't need to worry about them getting out of sync from each other. It's just that instead of running from test debug, I got to run from debug. Hold on. Do I need to worry about C test, or it should actually know where the tests are? It just doesn't. It's not going to tell me exactly where. It's just going to say it ran Chatroom plugin test, but doesn't tell me which directory it was in. That should be fine though. What if, just to make sure, I can get rid of test debug, right? rmrf debug. And then C test debug. So this should still run the tests. Okay. It still makes a directory there. It just doesn't put any files there. I guess that's fine. So, this fixes an irritating problem. Chatroom plugin. Fix build sequence issue. If the plugin was changed, but the tests for it weren't, the tests were ending up testing an old version of the plugin. To prevent this from happening, rather than having a post build step for the tests that made a copy of the plugin, just build the plugin and its tests into the same output folder. Yeah. Alright, so we have our chat room. You can set your nickname. You can chat. We don't have one for if you leave, though, do we? We at least don't have a test for that. So let's add a test. We'll call it leave. So Bob joins the room. Alice joins the room. Then we'll have Bob leave the room. Or Alice leaves the room. And then Bob will peek and will not see Alice anymore. Just sees himself now. So Alice, how do you leave the room? It's you break the connection. Or you close the connection. So it'll be ws1.close. And we'll just give no reason. Where's my command to run the tests? There we go. Okay, so leave works. Let's check that in. Chatroom plugin. Add a test for what happens when a user leaves. I guess we could also post a message saying Alice has left the room. Should we do that? We could do that, right? So a leave and a join maybe. So join. We'll have Bob join the room. Alice joins the room, and we'll just expect Bob to see a message about Alice joining, but not expect Alice to see that. We should also have a test for when Bob joins twice. He shouldn't see himself. No one should see him join a second time. Can we build that? We could maybe build that into this other stuff. Because we have Bob join a second time, right? Right here. Yeah, we'll do that. So we'll just have this one be the simple case. Expect Bob to see a message about Alice joining, but not expect Alice to see the message. So the expected message. Type join nickname Alice. We'll expect Bob to see it, but we'll expect, where is it? Expect. But then we'll expect that Alice doesn't. Bob should see the message, but not Alice. Right, so we need to build that in. So Bob isn't seeing Alice join the room. Let's add that. I think what'll make it easier is for account, we'll have, hold on. I'm thinking like if you join once, we could have a flag here like present in room. But if they're joined multiple times, then we kind of need a counter. But that's maybe a premature optimization. Maybe what we can just do is count every time. Yeah, let's do that. So we join when the nickname is set, correct? Right here. So let's first do a check to see if they were in the room before. Bool already in room. False. For const auto user in users, if user dot second dot nickname equals nickname, already in room equals true and break. Then we'll say if not already in room, we'll iterate again, only it can't be const because we're going to say user dot second dot WebSocket send text message encoded response encoded. And oh, okay, I thought that's what I called it. Where was it? Get. It was in tell, right? Response encoding. I want one of these things. Type is join. Nickname is nickname. And we send it to everybody. Oh, but we don't want to send it to the person who joined. Because that would... I'm just thinking the person who joined doesn't need to know that they were the one who joined, so we'll have it skip them. If user.second.nick, which means I guess we need to put this one first. We do this after we make sure they're not already in the room. Then we add them. Then if they said they weren't already in the room, then only if the nickname is not equal to nickname, we send the join message. Let's try that out. Ooh, that broke a bunch of things. Oh, because we're seeing that join everywhere now. So that's cool. We can add that to the test. So 365, we see a join there. Oh, I got that name wrong. That 356. Right, so this one gets told about Bob joining. So let's clear that first because we don't care. Where else? 468? 469? Right, so Alice will be told that Bob joined the room. Because they're both Bob and Alice connect, and then Bob formally joins the room by setting the nickname. So Alice gets a Bob has joined message. So let's clear her messages first, because we don't care to see that at that point. And then 554. It's again the same thing. We don't really need to see that. We don't really care about Bob joining. It's about Alice joining that we care about. 606. Same thing. Okay, good. More failures. Okay, so Bob is seeing himself join. That's not cool. Oh, yeah. Before they set their nickname on this WebSocket, they'll see themselves in the first one. Okay, so tell. Okay, tell is seeing the join. So where was that? 487. 571. Should clear both of them actually. And 629. Yeah, these are distinct faces. Should always be clearing before and after, really. Okay. So 574. Oh, cleared it at the wrong place. Alice, okay, we'll fold these. They really should be folded together anyway. Alice joins the room. Expect Bob to see a message about Alice joining, but don't expect Alice to see the message. So, expected message. That's what we expect Alice to see, is just the success. And then what we expect Bob to see that. And let's order them. So we expect Bob to see that Alice joined. We expect Alice to see that the set nickname was a success. Oh. Yeah, the join should not have an array there, should it? Okay, the capitalization's not the same. Yeah. There we go. Right. Okay, so this was all about Chatroom plugin. Publish. Well, tell other users when someone joins the room as not a lurker. Basically, we're defining a lurker to be someone who has a WebSocket connection, but they haven't set their nickname. And I think I had one for leave, right? Leave. Was this just a copy of the last test? No? Oh, right, I did one, yeah. So I expect 2 messages, right? So how best to express this? Maybe make it a vector that's outside expected responses. And then this will be expected responses pushback expected response, and then just turn around and make another one. And then we can just say expected responses. Messages received 0. Yeah. So we won't clear it here, we'll clear it here. So this will cause one message, and then this get nicknames will cause another one. So the first type will be a leave. Nickname Alice. And then when we list the people in the room, it should just say Bob. So right, we're not getting the leave, we're just getting the nickname list. So because we're not publishing the leave right now. So it's going to be something like this. But when they leave. So where's leave? That's the remove user, correct? Oh, we're not checking that open thing either. Actually, that's fine. What we can do is we can wait until the connection is actually removed. That's from our worker thread, right? Where's worker thread? Worker. Right, users that have left. Right, so we can do it here. We can say still in room. And we'll assume, right, we'll assume false. We should cache the nickname here. We don't do that. We say if not still in room, yeah, then it's type leave. And we don't have to check this anymore, actually, because they won't be around to receive it. There we go. Although this might race, right? Might fail because we're racing a worker thread when we do that. It's actually difficult to make it fail. It should be racing this worker thread. What happens is this close of the WebSocket followed by this checking of the messages received. When we start this process of closing the WebSocket, this checking the messages received is racing this worker thread, which is sending the leave message that we're expecting here. So, bit of a race. I suppose we could just we could block until that's closed, because it happens here where we clear it. That's where the other side of the WebSocket closes. Yeah, let's do that. So that would be yeah. If we're gonna wait, we need a condition variable, and we'll need a mutex. Yeah, so we set a text delegate. What we're going to do is set a close delegate. This comma I, and it's status code and reason, I think it was. Code and reason. So we'll have some flags here. I guess we'll put it near the WebSocket. What to name it? WS closed. And then num mock clients. We just have to initialize that. These flags indicate whether or not the corresponding web sockets have been closed. Classed? Closed. So, initialize it to false. And then in the close delegate, we're going to lock guard. Oh, we forgot to make the mutex. And the condition variable. This is used to synchronize access to the WS closed flags and the WS wait condition variable. WS mutex, and then this is used to wait for or signal the condition of one or more WS closed flags being set. For now, that's what it's used for, right? Condition variable WS wait condition. All right. So lockguard decal type WS mutex, and then lock it, and then WS closed I equals true, and then WS wait condition notify all. Right, and then we'll here, so that we prevent the race, we'll wait for it here. Unique lock decal type WS mutex again, and then WS wait condition dot wait for, and we'll assert that this is true. This ends up being returning true. In other words, that it actually happens. Wait for lock a maximum of, I don't know, seconds, 1 second, and then the condition is this. Return WS closed 1. So that blocks waiting for the WebSocket to be closed. We close our end, we wait for the other end to be closed. So that should prevent a race. Oh, we're not getting the close back. That's not expected. When we close it, we should have gotten it closed. What happens when we do this? Well, hold on. Let's set the breakpoint there. And then what I expect to happen, if this plugin, if this is working correctly, it should go to here. Okay, it did. Okay, there's Bob and there's one without a nickname, which is the third one that isn't used in that test. So it's not still in there. Oh yeah, okay, so it's going to send the leave message. Right, so we did have a closed user, Alice closed. So I expected there the WebSocket destructor to be called, but maybe I'm not thinking about this correctly. Oh, there are 2 strong references. Okay, that's the. Is it because the test itself has a handle to the WebSocket? No, that shouldn't be. That shouldn't be. Where's the WebSocket? 2 strong references to the WebSocket, really? What are the 2 strong references? So I suppose this doesn't work where if I set a breakpoint to there, and then one in the WebSocket destructor, oh, it's defaulted. Maybe that's the problem. We're not actually calling close on the WebSocket, it's just kind of destroying it. I think that is the problem. Never calling close on it. We should call close on it, shouldn't we? And if you destroy a WebSocket, shouldn't it? Yeah, it should probably. Okay, let me make a note of this because I don't know if I'll get to it tonight. Destroying a WebSocket that is still open should cause the Well, actually, it will. It should cause the connection to be broken. It will because in this impl, I wish I couldn't find, but let me scroll and find it. It should hold only one reference to this connection, so that will be closed, right? But okay, yeah, it's already doing it. I don't need to worry about it. It's just we're not calling the clean close here, which we probably should. So let's do that. So that'll be here, I guess. So we'll say user entry second dot ws dot close. Or should we should do it when we receive the close, right? Set close delegate. Yeah, we should just do it here. So it would be no. We should go to this remove user. Yeah, here we should do it while we have the mutex. So here. We sort of want to echo back the same code and reason though, right? So let's pass that in. This is the WebSocket status close status code. This is the WebSocket payload data from the WebSocket close. So remove user. Code reason. There we go. Now we should get the close, which shouldn't block. There we go. So now that's better. It won't race the receiving of the leave doesn't race. Actually, and that these messages receiving both of these messages correctly doesn't race the actual leaving of Alice from the room, because this will block until the chat room has echoed back the close. Oh, hold on. That's maybe too soon. Yeah, okay. I suppose if we skip closed users when we... No, hold on. The leave is still done by the worker thread, right? So... it's still a good idea to close the WebSocket early, I think. But it doesn't prevent us racing here. I suppose we could wait until... Yeah, we could just wait until we've received something, right? Yeah, let's do that. So instead of waiting for the WebSocket to be closed, let's have this wait condition. This used to synchronize access to the messages received. Variables. So we won't have this closed thing. Well, let's have them both. It's good to test both. The WS closed, messages received, and receive and variables. Just call it mutex, and we'll call it wait condition. This is used to wait for the condition of one or more messages received or WS close. Messages received updates or WS closed flags being set. There we go. It's just that messages received. Here we should do the same kind of block and notification. This became mutex, not just the WebSocket now, and this is just wait condition. Same thing here. It's just we're not going to wait for WS closed. We'll wait for messages received to not be empty on 0. So yeah, this when we receive a message, it'll be hopefully this leave, and then we'll expect that we get it followed by our response to our get nicknames, which happens synchronously. Yeah, I like that better. So let's see that in action. Actually, we can combine them both, right? WS closed 0 and it's 1, isn't it? Yeah, if I put 0 here, it should time out because the Bob's connection won't have closed. Right? There we go. Cool. So race avoided. It'll block until Alice's connection is fully closed and Bob is told about it. Good, I like that a lot better. So we added the leave. We fixed the fact that we never cleanly closed the WebSockets. So we did both of those. So actually, let's just, yeah, we'll combine them too. Chatroom plugin. Announce when users leave and cleanly close web sockets. Well, let's make that an aside. Also, cleanly close web sockets when after users leave. Commit. Did I not? Okay, that was weird. Getting a little bit of lag. How's my stream health? Stream health is good. Getting just kind of weird. Whoop. Anna, I got keyboard issues. It's mostly it's my brain is scrambled for some reason right now. My words are coming out scrambled. My hands aren't on the keyboard right. Maybe it's a sign I'm getting old. Not yet. I don't want to be old yet. Okay, we're all up to date. Let's run all of our tests. They all passed. I think we're ready to move on. Which is, we're going to handle upgrading connections in the server, which allows us to plug WebSockets into the server, which will then clear the way for actually having a web app talk to our live chat room. Okay, cool. Everything's passing. So let's do the integration support. So what we want to do is in HTTP tests. Where is that? HTTP test server test. We want to have a test for upgrading connection. So server test, upgrade connection. So it's going to be kind of like a get send. Where do we have that? Request timeout. Okay, inactivity timeout. You collapse everything and pick one of these. Okay, where's one? Client request in one piece, I suppose. So let's copy this guy. Upgrade connection. Have I really been going for 2 hours? Yep, I'm going for 2 hours. Alright. Upgrade connection. Transport dependencies. Right. Mock timekeeper. We don't need to know this yet. Don't need to know this. Don't care about this. Right, so here we go. So we'll craft a special one here. Hold on. Do I have? Oh, okay. Kind of copied the wrong test. I need one where we have registered something. Yeah, we need this registration of a delegate. Yeah. So hold on. Let me take this test and we'll use that as a starting point instead of what I had before. That's right. Set that up. I don't need to do this though. We need to keep the client though. Where is request? Oh. I guess I made it once and then reused it. Don't need that assert. Okay. Don't need to hold on to these requests received. Okay, I do want to hold on to the connection though, because we're going to play with that. So, connection, upgraded connection. Right, okay, so what we're going to do is we're going to make the resource delegate say 101 switching protocols. That's the right. I always forget, so I need to look this up every time. That is in RFC 7231, I think. 101 switching protocols, yes. Okay, so 101 switching protocols, and then we should set the right headers. So set header connection upgrade. Although it doesn't really matter. And then we'll say upgraded connection equals connection. Right, so const auto response. So we expect 101 upgraded And then we will assert actually that the upgraded request, the upgraded connection is the same as the original connection. Then what we want to do, okay, this is getting long, so let me break this up. So first, set up the server. Start connection to server. Well, really, this should happen first. Actually, it's not really start. It's connect to, well, connect to server and then send a request that should trigger an upgrade. And then after we double check that we'll set it to null pointer. And then we'll send the request again. This time we'll send, yeah, this time the request should not be routed to the resource handler because the server should have upgraded the request. It should have relayed connection to the, should have passed, well, really should have relayed connection to the request handler. In other words, the server shouldn't continue to respond to the request. It should be, once you upgrade the connection, the resource delegate is supposed to handle it from that point. So in other words, like we would have passed it off to a WebSocket at that point. So register resource handler that will upgrade the connection of any request sent to it. And let's make a bool. Connection upgraded. Request received, maybe? What we'll do is we'll set that to true. And let's set it first thing. So expect true request received. And then when we send it again, let's clear here. When we send it again, we'll expect that we don't get anything back. We'll also expect false that the connection's broken. Shouldn't be broken either. And expect false that request was received by the delegate. In other words, the server should have backed off by then. So right now that test should fail because the server's not going to back off on the connection. HTTP server test debug HTTP tests. Yeah, so right here, so we're actually getting data back from the server. So it shouldn't, this 101 should tell the server to back off. So HTTP server, so resource handler, resource, is it data received? I can't remember where we handle this stuff. Data received, I think. Yeah, so here's where we call the handler. I think here's the right place. So we'll say if response status code equal, is it just 101? Yeah, we'll just have the API be that if the resource handler set the status code to 101, then it's taken over. So that's, I think it's easy enough to just say connection state connection equals null pointer. Right? Actually, I don't think my test is valid, because for this to work, when we upgrade the connection, we need to set we need to replace the delegates basically, because the server's delegates will be still registered. So let's register our own delegates here. Whoops. So how are we going to test that the server actually let go of its connection here? I guess the only way it would be to check the reference count. Where did we make the connection object? Oh, we made it right here. So it's mock connection, right? Let me expand everything. Oh, that was for one of our tests. Let's set up something where we can like get a function call when the connection object is finally destroyed. Hold on, and we'll block that out to make our test fail. Okay, so this mock connection is an open object, so we can just put it anywhere. So let's put it up here, I guess. This is a function to be called when the mock connection is destroyed. On destruction. Well, we don't have to say is null pointer because its default value is null pointer. So here, say if it's not equal to null pointer, call it. Then down here in our test, after we make it, we'll say connection on destruction equals, and we'll have a flag, connection destroyed. Capture it here. Okay, connection destroyed equals true. Semicolon. Okay. So what we can do is we can actually not null it out. After we, okay, here we'll release the upgraded connection. That should be the last reference to the connection. So expect it to have been destroyed. Assert true, connection destroyed. So we'll do that down here. Here, we'll release the connection. We needed it up to this point to make sure it got set in the upgraded connection, that it was correct. And we also are using it to send more data, of course. Yeah, so actually we're not going to send the same request. We'll just, does this need a vector? It does, so I guess we can repeat the request, right? So what we'll do here is we'll just have a string called data received after upgrading. And we'll add that to this capture list. The capture list is getting long, so I'm going to wrap it. So in the upgraded connection, we'll add any data that comes in here. And that needs to be captured again. There. So we'll just expect equal, the original request is the data received after upgrading, because that's what we're sending in. That should be good, right? So it should succeed up to this point until we have the server release the connection. Ooh, we got an exception. Awesome. So let's see how that happens. Set start a project and go. Oh, duh. We need to send it to the upgraded connection after that. How come it's not letting me do that? Oh, I guess we don't really need to release it until here, right? So is it failing correctly now? Oh, I forgot to clear that flag after we saw that it's received once. So here's a good place to clear it, and then cause the event which originally set it back up here. Okay, yeah, so connection is not being destroyed, but if the server sees it's 101, it should release it, and so that should be the last reference, and then it should be destroyed. Ooh. teardown caused an issue. That's interesting. Let's see that happen. Really? Oh, okay, yeah. We can't release the, yeah. We released the connection too early. We need to release it after we issued the response to it. Yeah, so let's move this. So if after we issued the response, if it's 101, we drop it. That makes more sense. Cool. One thing I'm worried about though is what if, let's say we put some junk after that. Hello. Technically, that's not part of this request, and so that should go to the upgraded. In fact, we should see that immediately come out this data received after upgrading. Right? Expect equal hello data received after upgrading. That's probably not going to happen. It probably gets lost, actually. Let's see. Yeah. So what happens, I think, is the server has this data. The data is put into the reassembly buffer. The connection's upgraded. We released the connection, but we still had data in the reassembly buffer. So we need to get that data to, really should be giving that data to the resource handler, just in case it needs it. Which is going to change the signature of our resource handler. Resource delegate. I think that's fine though. So what's the signature of reassembly buffer? It's a string. Okay, well, that's not too bad. We'll just pass it by reference. So we'll call that trailer. Trailer. This holds any characters that have already been received. Have already been is a split infinitive, right? Or what do you call that? Should be that have been all, no. This holds any characters that, actually I guess it's okay, that have already been received by the server but come after the end of the current request. A handler that upgrades the connection might want to interpret these characters within the context of the upgraded connection. Or post. Yeah, that's fine. So of course that's going to break a lot of stuff. Let's go fix it. Right here, right? Okay, another place. I wonder how many of these places there will be that we register resources. Or we call the delegate. It's a fair number of these, aren't there? Spaced out here and there. Resource delegate here. Actually, I can already see there are other errors down here. Yeah, similar things. Okay, but here we actually want the trailer to be put in, right? So will initialize data received after upgrading to the trailer. That was the whole point of doing that exercise. Okay. Didn't work. Oh, because we didn't send it, did we? In the server. Yeah, so before we release the no. Actually, we should have. Oh, no, we're sending empty. So this is the reassembly buffer, right? What is it? Connection state reassembly buffer. Ooh, wait a minute. Oh, yeah, yeah. Okay, never mind. We expect it, and then let's clear it out, so we don't have to expect it again later. There we go. So that's awesome. I think that's very cool. We just changed HTTP. Oh, we changed web server. Oh yeah, because the signature of the resource handler changed. Huh. That's weird. I'm getting like weird lag when I'm staging and unstaging. Okay, anyway. Add ability to upgrade connections. This is the server. To support, to prevent data loss in newly upgraded connections. Well, let's first off saying a connection is considered upgraded if the resource handler sets the response status to 101, which is switching protocols. To prevent data loss in newly upgraded connections, any data already received by the server is given to the resource handler in a new trailer parameter. And our Chatroom plugin should actually do something with that trailer, shouldn't it? We'll make a test for that. So update to match latest HTTP server resource handler API. Resource handlers are now given a new trailer parameter, which gives the handlers a peek at any data that came after request. The server already received, but came after the request. Because you might need it if you're upgrading the connection. So let's fix the bug we have in our chat, which is it's not handling any trailer right now. Chatroom plugin test. Where is that? Here it is. It actually needs a special setup, doesn't it? Because it's part of this. Where is it? Actually, it doesn't. Wait a minute. Hold on. Hold on. No, it does. It does. It's this right here. So yeah, we're just gonna ignore the common setup, right? Or should we handle? There was one test where we closed it and reopened it, right? Or maybe I just closed it and didn't reopen it. Yeah, so let's copy this first test and we'll do it in a way where part, should we put part or put the whole initial message? This message encoding will be in the trailer. Yeah, so hold on. Reopen a connection with part of the set nickname in trailer, with part of a set nickname message captured in the trailer. So first let's make the encoded message. Const auto message encoding equals that. Oh, this is going to be a little bit tough. Because we don't want to, we don't want to use the WebSocket. We want to like get the message the WebSocket would send and send it directly in 2 pieces. So instead of sending it, what would the WebSocket do? It's going to end up calling client. Yeah, so we need to call this directly. Because it's going to end up calling the client connections send data delegate. Oh, we're gonna have to deal with masking and all that junk too, aren't we? Oh boy. Okay, well, it's not too bad. So we did this in the WebSocket test, right? Yeah, we did this kind of a thing. So let's break it into pieces. We'll split it in half. So we'll say const auto message encoding first half equals message encoding dot substring 0 to the length minus 1, length divided by 2. And second half is from there onwards. So server connection 0. And we'll start a new string. Data, I guess. And it'll start with, it's 81, I think. Let's go look it up. WebSocket RFC 6455. So text frame is 1. Opcode, it's fin, so okay, it's 81 and then 80 ORed with the length, so it's this is gotta be that, right? And data plus equals 80 plus message encoding second half dot length. Do we include the mask? 6. No. So we add the mask then. Oh, I guess we should call it frames better than data. Oh, hold on. We want to... Yeah, let's break the frame in half. That'll be a much tougher test. So that means we'll do this breakup after this. So frame will be the whole message encoding length. And then this chunk. So it'll be message encoding length. So now it's fully encoded in the first half. We'll say frame first half. And frame second half is just frame substring frame length there. I don't get it. Oh, it needs a vector. Okay. That's easy enough. We just say standard vector unit 8 framed up. Oh, we're going to do this anyway. Frame second half beginning to the ending. But before we do this, we're going to break the connection. So ws0 dot close, and then we had this in a previous test, right, where we wait until it's fully closed. Wait until it's closed, and then we're going to reopen it. So to reopen it, okay, the WebSocket is going to close these mock connections don't care if they're closed, right? It'll just set broken to true, but who cares, right? Oh, broken delegate. Do we ever call broken delegate? No. Okay, so it's fine. So we don't need to repeat this first part or the second part, really. We don't need to do these either. Yeah, we just need to repeat this. And then this part, right? Yeah, okay, got it. So the open request, get chat, and then this is, we started opening again. Right, and then the server is told about the server end of the connection, and then we'll put the trailer in here as the frame first half. Then we, well, why is IntelliSense fighting me? Finish it. And then we send the second half. And then we'll expect the nickname is set to Bob. All right, let's try this. That was pretty elaborate. Chat web server. Other window, please. Web server chatroom plugin debug chatroom plugin tests. Cool. So it's not working because we're not doing anything with the trailer yet. So here's where we're going to do something with the trailer. Trailer. We need to pass it to add user. Add user. Trailer goes there. So documentation for trailer. So trailer goes to receive message. So after we, well actually before we set up the delegate, we will do if trailer is not empty, then receive message session ID trailer. My only concern is if this causes a protocol violation. I guess it just does nothing if it's yeah. Oh, hold on. This isn't quite right, is it? This isn't right. This WebSocket. It's right. It's after it's opened as server. Yeah. After we open it as a server, then we pass it in through the connections. Oh, how are we gonna? How do we? I guess open a server needs the trailer as well, doesn't it? Because this open here sets the data received delegate. And we need to like, yeah. Okay, so we need to change a bit more. We basically need to test in the trailer here. So everywhere open a server is called, we need the trailer as well. Need it there. Okay, trailer here. Get some documentation in there. This will any characters that have already been received from the connection. But come after the end of the request. Open request. And that's all we'll say. So where we use it is after all this succeeds, we will do impl receive data trailer if not trailer empty. That could actually, what is it? Oh, it wants a vector. That could actually cause an early close if the trailer is invalid. It's got junk in it or something. But I think that's okay. It might close before the caller even knows it's open. Begin trailer.end. No trailer. I guess we should have a test for that, right? So one thing's leading to another. I'm going to be doing this a bunch of times, I guess. These are all clean opens where there's no trailer. Okay, Chatroom plugin. Arg. It's probably in this WebSocket. We should have a test for a trailer. So that's open. It's like a combination of open as server followed by a message. So how about, where's the open as server? Complete open as server. So make a copy of this test. And we'll call it complete open as server with trailer. We'll have the trailer be, ooh. Yeah, so the trailer will have a little bit of a ping message. So that's a receive ping, right? No. Well, I guess we'll have to do the masking, right? Well, it doesn't matter because there's no data. So we'll put in the first few bytes. So 80. We'll put the first byte, which is 89. So we don't need to check any of this. Actually, let's use the Pong one. So we'll just say ws set Pong. We'll copy this, right? This thing here. Okay, how do we send in? Oh, it's connection data received delegate, yes. And that'll just be the next byte, which is 80. So first we'll expect true pong's empty, and then we'll send in the last byte and we'll assert that we actually completed a pong and it's empty string. Oh, needs a mask too, doesn't it? Test debug WebSocket test. Okay, that worked. I suppose this would cause it to not work, right? A lot of tests in WebSocket. Yeah, so and also if we remove that, that'll cause it not to work, correct? Yeah. So the WebSocket stuff is working. So what was broken before is somewhere in the chat room. So it's not doing the right thing with the trailer still. We are passing the trailer in, but that's weird. Let's trace that through. So set nickname in trailer. This one, right? Yeah. This right here. Chat room tests. What? I must have skipped over it somehow. Okay. That should be here. Okay, cool. And what's the trailer? A bunch of garbage. Oh, that's our masked. That's part of our masked frame, right? Right, so it's the first half, so it's 33 characters, right? Okay. Add user. Open a server. Trailer's not empty, right? So puts into the reassembly buffer. It hasn't been all received yet, so it returns. Cool. So it should return all the way out. But it'll be in that reassembly buffer. Oh, I never sent the second half. That's the problem. No, I did send. I sent it right here. Okay. Did I send it to the wrong thing? Let me single step in until I get to it. here it is. Okay, so it is, okay, here we go, receive data. Cool. Actually, I already had a breakpoint there. I could have just hit go. So the frame reassembly buffer now should have the whole message. Okay, so calls receive frame. Equals 1. It's a server, so it unmasks the data. Actually, you know what? I just noticed a problem. Protocol violation. We don't check the mask bit, do we? That's the problem. We should do that. Let me put that note on that. That's a bug. So, bug in WebSocket. No check to make sure mask bit is correct based on role. Received mask bit. We need to actually check that. Right now we're assuming it's correct. Anyway. Yeah, so here it got the text message. Setting the nickname. Yeah, okay. So why did the test fail? Why did that test fail? We never got a success. We should, right here. Oh, hold on. It disconnected. I think it's racing. It disconnected and then... No, we put something in there, right, to prevent the race? Yeah, we actually waited for it. It should have unregistered Bob. Actually, it should never have registered Bob. Well, let's see what happens. It should... Yeah, it's not in there. It's not in the room. Yeah, so it should set success. Success true, right? Oh, I think I might know what it might be. Message received 0. 26. No, it should receive it here. I hate stepping through the STL. Okay, send text. Actually, it's a good thing it caught it. I stepped too far. Okay, I stepped way too far, but let's step back out. Wait a minute, what's this? Okay, the other connections got a message that Bob joined, but this didn't get one. So what's wrong here? So, should have gotten. Hmm. WebSocket 1, I think, is screwed. Oh, because close sent is true. It's been closed. I see. We have we can't reopen a WebSocket once it's closed. We got to make a new one. So WebSockets WebSocket. That's the problem. I think that's the problem. Let's see. Arr, that's not it. Grr. Oh, maybe because I didn't build it. No? Okay, what's up with WebSocket 0? It's not closed. Oh, its delegates are all cleared now. Okay, so yeah, the stuff I didn't think I needed to repeat, again, I need to repeat. Okay, well. I guess I'll refactor that out then. And call this initialize client WebSocket. And we pass it to I. And we do this, right? How come that got weirdly indented? This method sets up the given client-side WebSocket used to test the chat room. This is the index of the WebSocket, of the client-side WebSocket to set up. Then we can call that I. My indentation is off. That's what was going on. That's all indented by one space for some reason. Oh, great. So when we reset that socket up here, I have to reinitialize it. A pain in the butt. There we go. All of that to test that the chat room can accept data immediately after upgrading its connection. So handle the trailer by sending it to add user, which forwards it to the web. So it really doesn't do much but forward it to the WebSocket. Most of the complication was in setting up the test for it. So chat room plugin forward trailer of upgraded connection to WebSocket. All right. And yeah, we added the trailer to the WebSocket. It handles it. What is this? Looks like I screwed up the indentation there. Let me look at that. Around line 528. Oh yeah, look at that. So yeah, so if we have a trailer, we pass it along to the received data function. That's all that we need to do. And we added a nice test for that. Handle trailer of upgraded connection by forwarding it. Oh, handle trailers of updated connections. Upgraded connections. All right. Should probably wrap up the stream soon, because since I've been going for over 3 hours. And we just did that. So that means WebSocket should be fully integrated with our web server and our chat room. So we should be able to connect to it if I had a web app. Right now, we're only able to connect to it through our unit tests, which isn't testing the fully integrated stack. But we do test a bunch of things, right? We test setting the nickname either during the trailer or when it's fully connected. We try setting it twice. We try reusing the room after unloading and reloading the plugin. We test tells, join and leave. So I think this is probably a good place to stop because all of this was in C++ and all of this is going to be in React. So we'll reserve that fun for Friday, I think. So let me do a recap and wind up the stream and talk about what we'll do next time. So this stream, we added all of these basic things you'd have in the chat room. Being able to set your nickname, being able to send a tell, and that included receiving the tells of others, getting notifications when people join or leave the chat room, and then we handled this corner case of receiving the first message from the chat room immediately as you're connecting. And we added the necessary changes in our web server so that we can hand off or relay the connection from the server to the WebSocket, which is what the chat room uses to implement the connections. So I would call most of this stuff, well, this first part was setting up a basic chat room that has everything our web app needs to make it a useful thing. And then this connection upgrade stuff it was really just loose ends to make sure that when we actually integrate this whole thing together, it'll actually work. So maybe not the most exciting stream, but we're getting things set up so we can have some fun in React, making a web app that actually interfaces with our real chat room. And maybe when we start working on that, I'll be able to have this running on a real server that my viewers can come in and interact with. That'd be cool, wouldn't it? So we'll plan to do that on Friday. So that's Friday, 9 p.m. Pacific. I'll be back on. At some point, I also need to fix this bug I noticed and also kind of clean up the JSON class. Not sure when I'll get to that. Probably what I'll do is I'll be collecting some of these issues under the to-do. Yeah, it's not perfect anymore, is it? And when I get enough of these to-dos like this, then I can go and dedicate a stream to fixing that stuff. I don't have one for WebSocket. So let me add that. This is a bug. So yeah, hope you guys enjoyed the stream. Next stream we'll be doing the web app side of this, which will be a little bit different than what I've done so far, which is all in C++. I'm going to embarrass myself by getting into something I'm not so comfortable with, which is client-side JavaScript, and we're gonna be making a in-browser app to interact with our web server. So I hope you can come by and join me then. It's gonna be on Friday 9 Pacific. So hope you found this stream useful or entertaining or both. I'll see you guys in a day or so. Have a good one. And before I go, let's see if I'm following anyone who's streaming right now, and if so, we can go host them. Actually, this guy, Adam C. Eunice, raided me last night, so maybe I'll return the favor. Not that there are many people on, but why not? We can send him a little raid back. So let me go get this set up, and we will go raid him right now. So stick around. This guy is an Australian game dev. Okay, that's not quite working. Oh, I guess it was working.
Please return. On Monday, we were. Oh, it takes a vector. Noise takes a vector. It's